All right, in section 3.4, we are now looking at the angles of a triangle. All right, so we've been looking at parallel lines and the angles that they form. Now we're looking at angles in triangles. All right, so this here is a triangle. Hopefully you have seen that before, all right? If you didn't know this was a triangle, this might be an interesting lesson for you. So in geometry, we denote triangles. We could call this triangle ABC just by using this little triangle out in front of it and then followed by the three letters A, B, and C. So this here, triangle ABC, where A, B, and C are known as the vertices of the triangle. All right, so where the sides meet, those are each the vertices. Okay, vertices. And that's vertex. Okay, singular is vertex. Multiple is vertices. All right, and then the sides are just the different segments. Segment AB, segment BC, segment AC. And then we have angle A, angle B, and angle C. All right, so now we're going to talk about classifying each of these triangles based on the number of sides that it has. All right, so classifications based on the number of sides. A scalene triangle has no sides congruent. So this right here, scalene, no sides congruent. An isosceles has at least two sides congruent. So note that it says at least two sides congruent. It could have three sides congruent. Okay, that's still an isosceles triangle, but it has to have at least two of the sides congruent. And then finally, an equilateral triangle. Equilateral triangles have all three sides congruent. So all equilateral triangles are isosceles triangles as well because they have at least two sides that are congruent, right? They have three sides that are congruent, which three is at least two. All right, and we can also classify these triangles as their angles, or by their angles. So an acute triangle has three angles, just like any triangle, and all three of them, excuse me, are acute. Okay, so every one of these three angles are acute, making it an acute triangle. An obtuse triangle has one obtuse angle. All right, we can see there's our one obtuse angle. It's actually not possible for a triangle to have more than one obtuse angle, and we will see that later as a corollary. A right triangle has one right angle. Again, it's not possible to have more than one right angle, and we'll see that later. So that's a right triangle there. And then an equiangular triangle. Equiangular triangles are actually the same as equilateral triangles because if they have three congruent angles, they also have three congruent sides. So all three of these sides would also be congruent. So equiangular means all angles are congruent. All right, so here's this big theorem. You guys have probably learned this before, but the sum of the measures of the angles of a triangle is 180. So if you have three angles here, if I have angle A, B, and C, measure of angle A plus measure of angle B plus measure of angle C is going to be equal to 180. They are not supplementary. Okay, they are not supplementary only because there's three angles. When we talk about supplementary angles, we're referring to a pair of angles. All right, so in this case, we have three. Three is not a pair. I think a pair of shoes is just two. All right, but they do add up to 180. And so now with this theorem, and remember that theorems have to be proved. If we were to prove this, and the way to prove it, I'm not going to show it out proof step by step, but let's just talk about how we would prove this, is what if we just drew, this is called an auxiliary line. So we're just drawing an additional line that doesn't actually exist. It wasn't given to us, but we know that there's always lines that can be drawn, right? Through any 2 points, there's exactly one line. So we're just going to draw this line and say that it's parallel to AC. Okay, we're saying it's parallel to this line right here. I'm going to call this angle number 1. We could call this angle number 2. And then this here's angle number 3. Well, if I look at this, if this line here is parallel to AC, well, I know that these are congruent. So angle 3 is actually congruent to angle A because those are alternate interior angles. And then same thing, angle 1 is an alternate interior angle with angle C. So those are congruent. And then I know that 1, 2, and 3 make up a straight line, so they have to add to 180. And then if this is the same as angle 3, and this is the same as angle 1, well, then angle C plus angle A plus angle 2 also has to add to 180. So that's why it's a theorem, because it needs to be proved, and we prove it using parallel lines. All right, so from that theorem, we now have 4 new corollaries. And corollaries are very similar to theorems and postulates in which we accept them because they're proved very easily just by using a theorem. So they can also be used on proofs. So the first corollary that we have is if 2 angles of a triangle are congruent to 2 angles of another triangle, then the third angles are also congruent. So if I have 2 different triangles and I know this angle is congruent to this angle is congruent to this angle, that tells me I know the third angles have to be congruent. And that makes sense, right? These two, if these two added up are equal to these two added up, and then you're trying to find the measure of the last angle, you would do 180 minus that. And if it's the same thing, well, that means that these angles must have the same measure, making them congruent as well. All right, corollary 2, each angle of an equiangular triangle has measure of 60. Well, if there's 3 angles, and they are all equal, and they all add up to 180, 180 divided by 3 is 60. All right, so that one makes sense. So that's why it says corollaries are easily proved by theorems, because they're really straightforward. Corollary 3 says, in a triangle, there can be at most 1 right angle or obtuse angle. Well, a right angle is 90. If I were to have 2 right angles, 90 plus 90 is 180, well, then you can't have a third angle. That's not going to work. And for obtuse, that's greater than 90. Let's say it's 91 even. 91 plus 91 is 182. We're already over 180 degrees. So the last angle would be negative 2 degrees. That doesn't make any sense. Okay, it doesn't make any sense. So there can be at most 1 right angle or obtuse angle. And then the last one, the acute angles of a right triangle are complementary. Well, if they add up to 180, and this is a right angle, a 90-degree angle, that means the other two have to add up to 90, making them complementary. So those 2 angles are complementary. Now, quite possibly the most important theorem that we are going to see from today. This theorem 312, and again, you don't have to memorize the number, but it says the measure of an exterior angle of a triangle equals the sum of the measures of the 2 remote interior angles. Let's just back it up a second and see what do they even mean. So in this diagram, we are just given that this angle right here is 115 degrees. Okay, if that's 115 degrees, so that's the angle we're focusing on. The exterior angle, what the exterior angle is what if we took the triangle and we extended the one side? If I extend that side beyond the triangle, the exterior angle is the angle that will be made on the exterior or the outside of the triangle. So this little diagram shows me, okay, well, here's my exterior angle. Then the remote interior angles are just the 2 other interior angles. Okay, so this one here and this one here. Those are my 2 remote interior angles. If this is my exterior angle, this is my interior angle, the 115 degrees is my interior angle, well, the other 2 are the remote interior angles. They're the interior angles that are not touching the exterior angle. You can see that this 115 is touching the exterior angle. That's why it's not considered a remote interior angle. But now let's just back it up and let's think about, well, I know that these two angles right here make up a straight line. So 115 plus the measure of that exterior angle has to equal 180. Okay, that's true. They make up a straight line, so they have to add up to equal 180. And then I also know that 115 plus the other two angles has to make up 180 because it's a triangle. They add up to 180. So 115 plus the measure of the two remote interior angles, and that's the two of them added together. So plus the remote interior angle, and that's going to be both of them. So the remote interior angles, that also has to equal 180 because this angle plus this angle plus this angle, the three angles of a triangle, have to add up to 180. Well, what could you do if you subtract 115 from each of them, right? Then you get that the measure of the exterior angle, this angle right here, has to equal these two added together. All right, has to equal those two added together. So for example, let's say that we have some triangle here. And then we have this, boom. And let's say I know that this here is 35. This here is 32. All right. This here, that's probably not very accurate. Let's just change it so it makes a little bit of sense. Let's say that this is 55 and this is 52. Well, what this theorem is telling us is that this angle right here is equal to 55 plus 52. So that would be equal to 107. And again, that makes sense because we know that that angle is supplementary with this angle. So this angle would have to be 73. And then if you add these three together, they have to add up to 180. The same way as if you just added these two together, they would have to add up to 180. So that's where the remote, the exterior, the triangle exterior angle theorem comes from.